Assume that hybridization experiments are conducted with peas having the property that for offspring there is a 0.75 probability that a pea has green pods. Assume that the offspring peas are randomly selected in groups of 42 and then complete parts A through C. Well, the given probability is that P is equal to 0.75. And the value of n is going to equal 42. First question says find the mean and the standard deviation for the numbers of peas with green pods in groups of 42. The mean of the binomial distribution is given by the formula where n is the fixed number of trials and p is the probability of success in one of the n trials. So mu is equal to n times p. Well, we know that n is equal to 42, we know that p is equal to 0.75, and now we're going to plug it into the formula to find the mean. So the mean is going to equal 42 times 0.75, which gives us 31.5. Now we're going to find the standard deviation. Now the formula to calculate the standard deviation of the binomial distribution, where again n is the fixed number of trials and p is the probability of success in one of the n trials, and also q is equal to 1 minus p is the probability of failure in one of the n trials. So here's our formula for the standard deviation, the square root of n times p times q. And so we first need to find out what q is. To find q, we need to take 1 and subtract p. We need to take 1 and subtract what p was, which is 0.75, which gives us 0.25. So therefore, that represents the probability of failure in one of the n trials. And now what we're going to do is, now that we have all the values to plug into the formula, we know that n is 42, we know that p is 0.75, and we know that q is 0.25. We're going to multiply those together and then take the square root of that. When we multiply them together, we get 7.875. We take the square root of that number, we get 2.806243, and then rounding that to one decimal place gives us 2.8. Now in part B it says use the range rule of thumb to find the values separating results that are significantly low or significantly high. Now recall that significantly low values are less than or equal to the mean minus 2 times the standard deviation. Significantly high values are greater than or equal to the mean plus 2 times the standard deviation. So recall that in part A we found the mean to be 31.5 p's and the standard deviation was 2.8 p's. Calculate the maximum significantly low value first. So we're going to take our mean, which is 31.5, subtract 2 times the standard deviation of 2.8, and that gives us 25.9. That represents the maximum significantly low value. Calculate the minimum significantly high value, where the mean is plus 2 times the standard deviation. So we're going to take 31.5 plus 2 times 2.8, and that gives us 37.1. Therefore, the values of 25.9 p's or fewer are significantly low, and the values of 37.1 p's or greater are significantly high. Now in part C it says, is a result of 36 p's with green pods a result that is significantly high, and why or why not? Well, we want to compare the result of 36 p's to the minimum significantly high value of 36.1 p's that are found in part B. Well, 36 is less than 37.1, and therefore the result is not significantly high because 36 p's with green pods is less than 37.1 p's.